Hello, dear students. Today we are going to solve Physics Unit 3, which is based on practical skills in Physics 1. Okay, and in this paper, you can use scientific calculators and ruler, and the time will be 1 hour 20 minutes. You can also read this instructions, informations, and the last one, advice. Okay, let's see. Question number one. A student investigated the acceleration of a trolley as it rolls down a ramp. The trolley was released from rest at the top of the ramp and allowed it to roll onto a horizontal surface. There was a single light gate above the horizontal surface as shown. So see, it's a trolley, and on a trolley we have a car, and here a light gate is okay, a single light gate is here. So first question is, the light gauge was connected to a data logger. Okay, it is connected to a data logger. The data logger recorded the time taken for the car to pass through the light gate. Describe how the student could determine the velocity v of the trolley as it passed through the light gate. So first, what we can do, if we can find out the length of this card. Okay, so the length of this card will pass through this gate. Okay, the length of this card will pass through this. So if it will enter and it will leave, so how many distance will be the length of that card? So first we will find the length of this card and divided by the time recorded by data logger. So velocity can be finded out the length of the card divided by time recorded by data logger. Okay, now question number B. The student repeated the procedure and determines four values of V. The values are shown in the table. When he in first attempt he find it out 2.07. In second attempt he find it out that velocity is 1.84. Third attempt 1.91, and in fourth attempt 2.1, and it's a maximum velocity. So calculate the mean value for V and percentage uncertainty in V, means velocity. So mean velocity is what? Sum of all the values of velocity, these four, this plus this, and divided by the number of terms. So here are four. So we will add all these values and divided by 4. So we will get the mean velocity as 1.98. And how the uncertainty is calculated? The uncertainty is calculated by the maximum subtraction minus, okay, maximum minus the mean value of velocity divided by 2 into 100 divided by the mean value. So you can use the formula of uncertainty and you will find it out that the uncertainty is 6.57 percentage, and you can round it off as it, yeah, you can write this as 7% uncertainty. Now the question number B, second. The student measures the distance s that the trolley travel on ramp. Determine the acceleration of trolley on the ramp. Okay, so here it is given that this length is given as s, and s value is 1.5 meter. Okay, so initial velocity was 0 because it uh, released from rest. Okay, and acceleration we have to find it out, and the velocity, as we find the mean value of velocity as 1.98, meter per second. Okay, so you can use here the formula u square is equal to v square is equal to u square plus 2as. So v is final velocity, u is initial, and this is 2 times acceleration times displacement. So you can square 1.98 whole square is equal to 0 square plus 2 times a means acceleration times 1.5, and after calculation we will get a as 1.31 meter per second square, okay, as acceleration. Now the third, a second student carried out the same experiment and determined a similar value for acceleration on the trolley on the ramp. Because of we didn't change any apparatus, state why this does not show that the results are reproducible. Because we don't change the apparatus, and we don't change apparatus, so the values will come similar. So you can see here, because of no change in apparatus. Okay, because no change in apparatus. Now question second, a student varies the power of a filament bulb to investigate the light emitted by the bulb. A student build a circuit to vary the power of bulb. Student use ammeter and voltmeter to determine the power of the bulb. Draw a circuit diagram that the student could have used. So we know to find out, voltmeter always connected parallel to the component. So if this is bulb, so voltmeter will be connected parallel to the bulb, and ammeter is always connected in series to the component. And this is what this is. Okay, we will discuss about this later. And here the voltage or battery is used. Now the B, the student shown the light from the bulb onto a light dependent resistor LDR. The student measured the resistance of LDR using ohm meter. Okay, the student plotted a graph of resistance of LDR against power of the bulb. Describe how the student could have obtained the set of data required to plot the graph. Your description should include how to ensure that data is accurate. So you can use here, calculate the power of bulb by measuring the voltmeter and ammeter readings and using the equation P is equal to VI. And here you can use a shortcut to remember this formula as not P is equal to VI. You can also remember this formula as VI is equal to P. So you can use VIP formula. Okay. And the second point, repeat this experiment for more than once and calculate the mean. Okay, this is the second point. The third point, vary potential difference to obtain at least 1 to 4 to 5 sets of data. Control distance from LDR to light source. Okay. Now see, the LDR is connected to the ohm meter using two connecting wires. The ohm meter reading includes the resistance of the two connecting wires. State why the student does not need to correct the reading, because you can write this answer because the resistance is negligible compared to the resistance of LDR. Okay. Now question number 3. A student investigated the force acting on a bracket. The bracket of weight W was attached to a vertical wall with a hinge at point C. The bracket was held horizontally by a wire attached to the bracket at point A and to the wall at point B. The wire was at an angle theta to the bracket and exert a force F on the bracket. Student hung a mass from the bracket at a distance of x from the hinge as shown. So, say here the point B, A, this is angle theta, and a force is applied by this wire at the point A, and this is hinge point, and from the hinge point at x distance from the hinge point, a mass is attached. Okay, this M mass is attached, and this is the center of mass of this bracket. Okay, so what is describe how the student could determine theta using the meter rule. So you can find either of the formula. You can use here tan theta to find theta, you can use cos theta to find theta, or you can also use sin theta to find theta. So for find if you will use tan theta, so you have to measure the length of BC and divide by the length of CA. And if you want to use cos theta, so you have to measure length of CA divided by the length of BA. And if you want to use sin theta, so you will have to measure length of BC divided by length of BA. Okay. You can use any of the three, any one of three for finding theta. So measure the length of wall BC and bracket CA using the meter rule, and you can use theta is equal to tan inverse BC by CA. Now describe how student could check that bracket was horizontal. So for finding out that bracket was horizontal, you can use here the Pythagoras theorem, because uh, if it's horizontal and it is vertical, if the wall is vertical and this is horizontal, so the angle between wall and bracket should be 90 degree. Okay. If it's vertical and it's horizontal, so the angle between wall and bracket should be 90 degree, and if it is 90 degree, so the square of this wall length and the bracket length, square of this plus square of this should be equal to square of this wire length of wire. So you can use here the Pythagoras theorem to prove that the bracket was horizontal. Use Pythagoras theorem as BC square plus CA square as AB whole square. Now question number C. Student adjusted the position of mass and measure x. For each value of x, student made corresponding measurements of F using force meter. The results are shown in the table. What is happening here? Over the time, we are increasing this x. We are okay. First, we attach this mass at this point, later on at this, later on at this. So first was x value was 5, 10, 15, 20, 25, 30, 45, 40, 45, sorry 40, 45, and the force values also changes to 2.6, 3.3, 4.4, 5.3, 6.2. So it's also increasing. The force value is also increasing because of center of mass is going towards the point A. Okay, when it was left side of center of mass of the bracket, so the combined center of mass was here, almost here, in between these two. Okay, in between these two. So A feels lower weight than here, left part. But after we changes the position of this mass, when it comes right to the center of mass of bracket, then the overall weight on the point A will increase. So therefore the weight about the point A increases, so overall force on X, so force F will also increase. Okay, and it can be, and it is already made find it out that at this distance the force is this, at 10 centimeter the F value is 2.6, and you can use, okay, you can plot this data on the graph. To criticize the recording of these results, original measurements are not recorded. Okay. Inconsistent significant figures for F, X only recorded to nearest center of mass. Nearest center of mass. So, see question number D. Student plotted a graph of F against X as shown. Okay. On x-axis we have plotted the X values. It is 5, 10, 15 centimeter, 25, 35, 45. So at 5 the value was 2, at 10 the value was 2.6, at 15. So okay, the values are plotted and a straight line can be made. So relationship between F and X is this formula. F is equal to mgx divided by L sine theta plus W by 2 sine theta. You can find this as the free body diagram. See, you can find that relation as F. Okay, let me erase something here. See, at this point, if this is theta, the force F will be F cos theta, and it will be F sine theta, and in downwards it will be mg here, it is mg, and it is W. So the relationship is given to us, and we don't need to drive this. We can directly use this equation for further calculation. So it is given L is the length of the bracket, and M is the mass hung from the bracket, and determine a value for W using a graph, and for theta is 42. Okay, so X, if we will compare this, Y is equal to mx plus c. So anything multiple of x is considered as gradient. Okay, so the gradient will be mg divided by L sine theta. Okay, that will be gradient, and c will be w by 2 sine theta. So here you can use the gradient. You can find, okay, you can find out the gradient by using the formula, or you can also check the value of c. Okay, you can also see here c value when it cuts the y-axis, or you can use this formula, but from here you can't get w, so you will use c formula as w by 2 sine theta. Okay, and c value is 0.8 is equal to w divided by 2 sine 42, because theta value is 42, and after using calculator you will get w is equal to 1.1 Newton. Now second, the value of g obtained from the graph is 9.64 meter per second square. The student concluded that the value of g obtained is accurate. Evaluate the student's conclusion. So what is the percentage difference? Original, we know the value of g is 9.81, so we will minus this 9.81 minus 9.64 divided by original times 100. So the percentage difference is 1.7%. Percentage difference is small, so method is accurate. Because of the percentage is very small, less than 3% can be considered as accurate. So it is 1.7 percentage. So whatever we have done, or in whatever the student done, it can be considered as accurate data or accurate. Now fourth question, a student investigated the resistance of some thin slice of silicon. Each silicon slice had the same length, same thickness, a different width. A different width. Conducting strips with fitted to opposite end of each silicon slice and connected to an ohm meter as shown. The student measured the values of W and corresponding values of resistance R. This is connecting strip, slice of silicon slice, the length and the thickness is given. The table shows students' measurements when the width is 14 millimeters, so the resistance is 33.6 mega ohm, and the value will be 1 by W 1 by W. Hmm. Relationship between R and W is this: rho L by area. As we know the formula of resistance, rho L by area, and at the place of area you can use W times T. So rho L by WT, and where rho is the resistivity of silicon, plot a graph of R on y-axis against 1 by W on x-axis. Use the additional column of table for your process data. So what we will have to do, you uh, take the inverse of these values for finding 1 upon W. So it will be 71 millimeters. Okay, millimeter inverse 56, millimeter inverse 38, millimeter inverse 27, and 19 millimeter inverse. And as we know, the millimeters is millimeters is 10 raised to minus 3 meters. Millimeters is 10 raised to minus 3 meters. So if we will take the inverse of it, it will be 10 raised to 3 meter inverse. Okay, uh, the millimeter inverse will be 10 raised to 3 meter inverse. And you can also say this 10 raised to 3 as kilometer inverse. Okay, so y-axis for resistance and x-axis for this. So we can plot this 19, 27, 38, 19, 27, 10, 20, 30, 40, 50, 60. So 19, at 19th the resistance is 8.7. At 19th the resistance was almost 8.7. Yeah, it will be around here. And at 27, 13.3. 27, 13.3. So you can erase this. This is not our answer. Here, here, and at 38, 38, 17.2, 56, 26. Okay. Yes, it is almost 15, and 56 is 26. Okay, 56 is almost 26. Yes, it is around here. And 71 is 33.6. 71 is 33.6. So this will be the correct graph. Now Second, determine t using data from the graph. We have to find t. As we can use this formula, rho L by t. So this is rho L by t. What will be this? This will be gradient, because this is x-axis and this is y-axis, and c as 0, because it starts from origin. So c value will be 0. So the gradient is rho L times L divided by t. Rho is given 4.0 into 10 raised to 6. Sorry. Gradient. Okay. This is 10.3 ohm meter and the length is 10 centimeter. So for finding out gradient, you can use the graph, and from graph the gradient value is 47500 ohm meter. 000 means you can do 475 kilo ohm meter. Okay, so for finding t, you can use rho L divided by gradient. Rho value is 4 times 10 is to 3 times, this is in centimeter, you can use 10 raised to minus 2, so it will be 0.1 meter. So it will be 0.1 meter. 100 divide, sorry, 10 divided by 100, 0.1, and finally the thickness will be 0.842 0.842 millimeters. Now B, student determine a value for T. She decided to measure the thickness of several silicon slices stacked together. She measured this thickness using a micrometer. Explain why this method gives a value for T with low uncertainty. Micrometer has a resolution of 0.01 millimeter. So low uncertainty. The uncertainty of measurement is divided by the number of slices, so percentage uncertainty is reduced. Now B. Second, the value of T obtained using this method was 0.8 millimeter with an uncertainty of 2%. Okay, so it can be the upper limit, the maximum upper limit can be 2% of it will be how much? The upper limit will be 0.8 times, and 1 plus 0.2, 0.02. So this will be your upper limit of t that can be obtained, 0.82 millimeters. Okay, deduce whether this value is consistent with value obtained from the graph. So by using the graph we get 0.842, which is 0.842, which is greater than 0.82 millimeters. So t determined from graph is above upper limit, so results not consistent. So result is not consistent because of uh, we get higher value from upper limit. Now the last question, question 5th. A student carried out an experiment to compare the speed of sound in air and the speed of sound in wood. The student used a long piece of wood, a hammer and two microphones as shown. This is hammer, this is wood, this is two microphones, and the distance between two microphones is 1.25 meter. The microphones were connected to a two-beam oscilloscope. The student hit the wood with a metal hammer, producing a sharp sound that travels through the air. The oscilloscope traces produced by the microphones and time per division dials are shown. So this is one division, second division, third division. So time per division is given and it is showing here. So you can see this is 1 division, 2 division, 3 division, 4, 5, 6, and 1, 2, 3, 1, 2, 3. So it will be 6, 6 plus 3 plus 3, 6. So that will be 5 ranges because of in one division there are 5 subdivisions, and this is 3, this is 3, so this will be 6. So 5 plus 1, and this will be 1 extra division. So 6 plus 1, 7, 7.1 division. 7.1, and this 1 division is 20%. So it will be 7.2%. It will be 7.2%. Okay, it will be 7.2 division. 7.2 division. So determine the speed of sound in air. Distance between microphones is given to us. The number of divisions between this. So the time will be how much? The number of divisions into times per division. So 7.2 divisions times 0.5 into 10 is to minus 3. Why? Because it was microseconds. So the time will be 33.6 times 10 is to minus 3 seconds, and you can use for finding displacement this formula. S is equal to ut. So S is 1.25 or 1.5. The distance between these are, this is distance between 2 5. Okay, and after calculation we will get the value speed of sound in air is 347 meter per second. Second part, the student then attached the microphones to the piece of wood, so they detected the sound passes along the wood. The distance between microphones was Again 1.5. Yes, 1.25 meter. Students Student adjusted the dial on the oscilloscope to 20 microsecond per division to display the trace from the microphones. A teacher commented that this was not correct setting. Justified teacher's comment. The piece of wood is made of oak. The speed of sound in oak is approximately 4,000 meter per second. Okay, so you can use S is equal to UT. S is how much? 1.25, and the initial velocity is 4,000 meter per second. That the time will be 310 microseconds. Okay, 310 microseconds. And if the time divisions is 20 microseconds, 20 microseconds per division, and if we will take as the not 7.2 as 8 divisions, then it will be 160 microseconds. So time on display is too short to show both peaks. Okay, to showing the both peaks, the time is very short in microseconds. Hmm. The student tries the same experiment using a rubber hammer. The rubber hammer compressed as it hit the wood, making a sound that lasted for a longer time. Explain the effect that using the rubber hammer had on the accuracy of time determined. Okay. Peaks would be wider. It would be more difficult to judge the position time of the peak, so between peaks would be less accurate. The student was given the following equation and data to find a value for speed of sound in oak. The formula is V is equal to under root E divided by rho. E is Young modulus of oak is 11.2 gigapascal plus minus 0.5 gigapascal. Density rho of oak is 650 kilo per meter cube with uncertainty of 3%. Assess which of these values was more significant source of uncertainty in the value of speed of sound. So which one? The Young modulus or density? Uncertainty of Young modulus of oak is 4.42%, and the uncertainty of density is 3%. So the uncertainty of Young modulus of oak is greater than the uncertainty of density of oak. Hence, Young modulus is more significant source of uncertainty. And now the paper ends. Unit 3 ends here. Okay, thank you for